So in this lesson, we're going to talk about linear regression. Just to review chapter 7, we talked about when you have a scatter plot, you want to talk about the DOFs, right? Direction, positive or negative. Outliers, like if you had a point out here, that would be an outlier here. Form, linear or non-linear, like curved. Strength, like this would be R equals 1, that's really strong. This would be R equals definitely a negative value because of the slope here, and maybe 0.7 or 0.8 or something, and so forth. We talked about closer to 0 is weak, closer to 1 is really strong. I didn't talk about this. If you tried to do, say, a quadratic regression, we don't in AP Stats, but you could, this value actually would, this data would fit really nicely. In fact, it fit perfectly. I can't draw very well, but it would. It would be a perfect parabola right there, or very close to it. And the R value, if you did a quadratic regression, would be actually like 0.9997. Every once in a while, as I say, a trick question on the AP where they ask about this. Honestly, this is a worthless value because remember what R measures? The linear strength. Well, this is clearly not linear, so it has no bearing on this graph. The R value of this would be, yeah, it's really, really high, but it's not a linear graph, so don't pay too much attention to that. Don't use an R value if it's not linear. So we're talking about the response variable here is the Y variable, and the explanatory is the X variable. We often predict Y. In fact, we usually use this symbol, Y hat, which means we predict Y. So that is what we're doing. We're using our X value to predict Y. Fitting a line means you're drawing a line that the calculator usually does it for us, or it's already been done for us in the problem, but you're following the trend of the data. It doesn't have to go through any specific points, but it has certain qualities we're going to talk about here, this regression line. So if we have some actual data here, if you type this into the calculator, you can actually do a scatter plot here and look at it. And that's a scatter plot. Again, this is our X explanatory variable, and this is our Y hat, our predicted Y value is the weights of the male. So we think that maybe height can predict or explain something about Y there. And in your calculator, if you type that in, you can actually insert a data statistics page and just click down there and say, height, and click here and say weight, and you can do that. To do a regression, all you do is you hit Menu, Analyze, Regression. You can choose either one of these two. Statisticians usually choose the A plus BX. It'll automatically draw that line and give you the equation right there, which is very, very nice. We have these things called residuals. And it's the difference between what you actually observed and what you predicted with your Y value here. So and it's the Y's of these values here. So like anytime you have something like here, this would be the predicted. On the line is the predicted value, and this one would be your actual value. So all four of these actual values, all four of these points are actual values, and if these points on the line would be the predicted values, and we're talking about the Y values of these points. So to calculate a residual, if you're cool, you'll say residual equals RAP, right? Residual equals actual minus predicted. Residual equals actual minus predicted. So if you look at this page here, well, we have some X values here. The average X is 5.1 if you average these four. The average Y is 8.4. And if you move this point around, you can see that the residuals change, right? Sometimes they're positive, sometimes they're negative. When they're above the line, you have a positive residual because the actual minus the predicted, the actual is larger than the predicted value on the line. So it would always be positive. In these cases, this is 8 point something, 1 point something, -1, and -9. If you add all those up, you get 0. Does it matter if I move the line? What's the sum of the residuals? It always adds to 0. Residuals will always add to 0. That's a really interesting idea. They also always go through this point here, this X bar, Y bar point. So keep that in mind as we move forward. A regression line will always, that's not actually a point of data. That's just, it'll always go through that point. It's kind of a neat thing that happens there, the mean point there. If it's positive, your prediction falls too low, and the actual value is above the line. You can see these actual blue points are above the line, so you have a positive residual. Same thing here for negative residuals, but opposite. Let's see if we can calculate this. There'd be two ways to calculate this. If we want A, we could just kind of draw this residual in here. Say, well, it looks like 2 units, so A is positive 2. It's positive because your actual value minus your predicted value would be a positive number. This is like 2, 4, and this is 2, 2. If you look at the y values, the actual y value is 4. The predicted y value is 2. The actual minus predicted, wrap, is 4 minus 2 is 2. So it's a positive residual. Here B looks to be about negative 1.5, so negative sign, negative 1.5. And B would be, if you think about it, that's the predicted value would be, the predicted y value there would be about 3.5. The predicted, or the actual y value is about 2. If you look at the ordered pair, I'm talking about the y values there. So 2 minus 3.5 is negative 1.5. You can actually show this on your calculator if you want to show off. You can go back to your data there, and if you hit Menu, Analyze Residuals, there's a couple options. One of those is Show Residual Squares, and so they can actually total those. In this case, the residual squares total to 7,120. That's the area of each one of these squares. And the idea of these residual squares is that you're getting like, this is your residual. These are your, this is your residual here. And we're making squares out of this, right? So the same length square all around. If you add up the area of that square, plus the area of that one and that one and that one and that one, it sums, in this case, for this data, 22563. That's not the regression line. I was just playing with my line and moving it around to see if I could get the least common. That's not the smallest amount of square area. The calculator did that automatically when it did the regression line. This is the sum. This is the least squares regression line. It's the least squares because 6,120 is the smallest. That's the best line we can draw that has the smallest area for the squares there. And you can do regression on the calculator, but notice something that's interesting here is this is what the calculator gives us, but we don't write that down. We always use words for x and y for doing regression. And so we're going to plug in, instead of x, we're going to call x what it is. X is the height of the male. Here we're going to call it weight. And notice we have a little hat on top of that. So you just put a little hat on top of your variable there, or you just say in words predicted weight, and that would be okay there. But we always use words as statisticians instead of x and y when we do regression. This is from your formula sheet. You'll notice this is very similar to like an mx plus b. One way of thinking about this is like the old b, as in b naught. Think of that as an O for old. That's the old y-intercept b. This is kind of the new b. It's the slope. So the slope is b1 in these formulas. And that might be worthwhile knowing. Of course, it's on your formula sheet. You don't have to memorize it. And this is kind of our new equation for the y-intercept if we wanted that one. This is kind of interesting. This is the standard deviation of y divided by the standard deviation of x. Kind of like a rise over run times r there is how we calculate that slope for the regression line. I'm going to skip those for a minute and come back to it. I want to make sure to do two things. I want to talk about residual plot. So the other thing you can do on your calculator, I'm going to hit Control Escape to undo what I just did. It's the escape or undo function. If you hit Menu, Analyze Residuals, and we show residual plot, it actually plots something down here called the residual plot. You're looking for something that doesn't have a pattern. When I say that, I mean like, if this all formed like some nice curved pattern here or something and all the points were kind of like that, I would know that this linear model is not a good fit for the data. I would know that maybe there's too much of a curve in the data, and it shows up a little bit more closely here. You can see, though, in this data that the linear model is a good fit because what we have here is no pattern. You want no pattern in the residual plot. That's ideally what you're looking for. It sounds strange, but we want no pattern. Always do a residual plot when you do regression. You want to look at that. You want to look at R, but there's no pattern. You want to look, is it kind of scattered around? You might find a curved pattern, possibly quadratic or something. And we're gonna see it better here. So always do that. It's a better indicator than correlation to R. So we can find R and do that. By the way, in the calculator to find R, if you add like a calculator page and hit variable, you can see that once you've done a regression, R and R squared would be stored in your calculator. In this case, R was 0.644. So it's not strong, but it's definitely a positive relationship that we have there, just generally speaking. And here, the last thing is always check the conditions. Now, I want to get to this page right here. So, here we are. So if you get here, we want to get the predicted value here. So again, our equation is going to be y hat equals b naught plus b sub 1, which is our slope, times x. And so you just want to know where these things are. In this case, under constant, that's going to be where we find our constant, that's our coefficient there. That's our y-intercept. Under coefficient, and next to the x variable here, we find our slope. And this guy is always our x variable. So our x variable in this case would be fertilizer. Here, crop versus fertilizer, we know that crop yield would have to be our y variable. So we're ready to write our equation. It would be crop yield. I'm just going to write crop. And so we go b naught would be the y-intercept, which is 36.4, plus the slope 0.058 times the fertilizer. And I'd write that out. I'm just going to abbreviate it right now. And that would be our equation. You need to be able to get the equation from here. There's a couple more things on there. This is the standard error of the slope. We don't need that yet. This is the p-value. We don't need that. That's the t-value we don't need. This one we might use this chapter. It's the r squared value that's given to us. And so this doesn't tell us if it's positive or negative. It doesn't have direction. But if you take the r value and square it, that's what that is. So we know the r value now. We could just take the square root of 0.845 and we'd have r value. This is standard deviation of the residuals. But again, this is how you can do that. And so you could practice this one to make sure you know what you're doing. Again, you're looking at constant. So this is your y-intercept. This is your slope. This is your x-axis, x variable, and weight versus day. So this is your y. So this is your x. Again, this is your, b naught. This is your b. That is the end of the screencast.